So we're in section 3.6 today, solving multi-step inequalities, and that's basically just two-step inequalities. In example 1, we're checking solutions. So they give us a value, and we need to plug in that value into the inequality where we see the variables, and see if that value makes the inequality true. Now we know that there's more than one solution for an inequality, so it's very possible that both of these values could be a solution, or could make it true. All right, the only way we're going to know that is if we get in here and plug in the numbers, check the solutions. All right, so with 5, we're going to do 5. Is that going to become 55 when I plug in a 5 for x? No, it's going to be 5 times 5. Minus 10 is greater than 2 times 5 plus 4. Go ahead and simplify both sides, and let's see if this value makes the inequality true. Right, so I get 15 on the left and 14 on the right. So is it true that 15 is greater than 14?
Yes.
Yes. Okay. All right, go ahead and do the same thing with negative 2. So when we plug in negative 2, what's 5 times negative 2 minus 10? Negative 20. And what's 2 times negative 2 plus 4? 2. No, whoa. Negative 4 plus 4 is 0. So is it true that negative 20 is greater than 0? No. It's not true. All right, so negative 2 is not a solution for that inequality. The first section of your homework is exactly like this. Actually, it's the same inequality, just at different values. Okay, so numbers 8 and 10, or I'm sorry, 10 and 12 are just like this. All right, next example, we're looking at solving some of these multi-step inequalities. All right, so 19 is greater than x over 9 minus 5. We need to solve this, and we solve it the same way that we would solve a two-step equation. We have to move what is not connected to the variable first. That would be the number that's by itself. So if I want to move negative 5 to the other side, I need to add 5 to both sides. 24 is greater than x over 9. I'll give you a minute to try to come up with your answer. So now we multiply both sides by 9. Did y'all get 216?
Yes.
Okay, and when we graph this, we have to be careful about which way our arrow goes, because it looks like a greater than sign, but we know that we must read the variable first, so this is actually x is less than 216, or what this means is all numbers must be less than 216 to make the inequality true. So open dot going left. All right, I want you to go ahead and try to solve the second one now. We start off by adding 6 to both sides. All right, I know that got a little messy right there, but x over negative 4 is greater than or equal to 1. Negative 5 plus 6 is 1. What do we need to multiply both sides by? Negative 4. What happens when I multiply by a negative? You switch my inequality. Very good. All right, who switched your inequality? Did you remember? Okay, very good. All right, and then closed dot and arrow going left, and if we switched our inequality, we probably got that right. Okay, so that's it for this slide. Let's do a couple more. Now the first one has, what property do you see here? What property do you see there? No, it does start with a D, but it's distributive property. Go ahead and distribute the 4 and rewrite your inequality. Okay, so we get, did we get 20 minus 12b is greater than 4b plus 4? Yes. Did y'all get that? Okay, so what do you see that's different about this inequality versus the others? Very good. There's a variable on both sides of the inequality. Now we know if there's two variables on the same side of the inequality, we can just combine like terms. But when they're on opposite sides of our inequality symbol, we have to move it to the other side. We do that by opposite operations. But which one will we move? Negative 12 or 4?
12.
We move negative 12 because that is the lesser of the two values. It's the lesser value. So if we're moving 12b over to the right side, we now need to move everything from the right side over to the left side, right? Because we have to get the variable by itself. So what we're going to start doing is kind of this, you could call it a swing step or something, but we're basically moving the variable over here. So now we're going to move the number over to the left side. It's just a swing. So we know if the variable's on the right side, our numbers have to be over on the left side, so we subtract 4 from both sides. Basically just saves us some time to do it that way. And now we can rewrite our inequality that 16 is greater than 16b. And now go ahead and solve for b. So we divide both sides by 16, but how are we going to read this answer? How do we read this answer? It's really important that we read this correctly. How do we read it? B is less than 1. We have to read the variable first, and when we read it that way, it's an open dot on the 1 and arrow going left. All right, now the next one problem is different because we have a fraction, but then we have something that needs to be simplified in our numerator. Well, can we just add x plus 5 together? Are we allowed to do that? No, they're not like terms. But the first thing we want to do is get rid of our denominator, get rid of this fraction. And how would we do that? Multiply both sides by 3. Okay, so you have a problem, maybe 2 on your homework tonight, that deal with this type of a fraction. So you just get rid of your denominator first, and now rewrite your inequality. X over 5 is less than or equal to 6. Or, I'm sorry, not x over 5, but x plus 5 is less than or equal to 6. So now, what would I do to both sides? Subtract 5 both sides, and I get 1. X is less than or equal to 1. Okay. And timeline. 1, 0, negative 1, 2, and 3. All right. And open or close dot on the 1. Closed. And arrow going left or right? To the left. Very good. All right, so solving inequalities. In some ways, this is nothing new, right? Because we've solved equations the same way. We've even solved inequalities. It's just kind of bringing it together. Maybe, you know, it is new in the sense that we haven't solved inequalities with variables on both sides, okay? All right, so that's it for example 2. Let's see. Now this is going to be example 3. There's just a little typo on there. It should say example 3 with variables on both sides. So let's explore this variables on both sides a little bit more just to make sure everybody's on the same page. And we've talked about this for several weeks now, that we need to focus on moving the lesser value of the two, right? And we do that to avoid having a negative coefficient. With an inequality, if I have a negative coefficient and I divide or multiply, I've got to reverse my sign. And that's where we sometimes see mistakes being made. So in order to avoid that, if we just look at the 2 and we say, I move the lesser of the 2, then we don't have a negative coefficient. So that's a ideal situation. All right, so go ahead and write this inequality down if you haven't already. Negative 3x minus 3 is less than 2x minus 83. So which variable do you think you would move? Negative 3x. So if I'm adding 3x over to the right side, what am I going to do with negative 83? I'm going to add it to the left side. So I'm going to add 83 over to the left side. Do you see how we did that? We move the variables to the right, so we're moving our numbers to the left. We make our cancellations, and we get 80 is less than 5x. Go ahead and finish solving that one. Okay, so yes, JC.
How did you get 2 83s and 2 3x's?
Okay, great question. So now, yes, we are going to divide both sides by 5, and we get this as our solution. And how would we read this solution? How would we read it?
16 is less than x.
No.
X is More than
X is greater than 16. We have to read it that all numbers must be greater than 16 in order to be a solution. And when we read it that way, we're going to get the arrow right. Okay? It's got to be greater than 16 to make that inequality true. I want you to go ahead and do the second one, start to finish. Right? So, what do we do first? What do we do first?
Add,
No.
subtract 3m.
Subtract 3m, because that's the smaller of the two values. I want to avoid having a negative coefficient. So if I subtract 3m to the right side, what am I going to do with negative 30? I'm going to add it to the left side. Very good. Add it to the left side. My 3m's cancel. My 30, what am I left with? 22 is greater than or equal to 2m. Divide both sides by 2. How do I read my answer?
11.
How do I read it?
Greater or equal to. Less than.
M is less than or equal to 11, so closed dot going left for less than. All right, just like we saw with equations, sometimes I'm given a total, and the total goes on one side, and the rest of it goes on the other, and then sometimes I have two different, you could call them scenarios, that I'm matching up against each other. All right, in this case, let's see which one we have. It says your school soccer team is trying to break the school record for goals scored in one season. Your team has already scored 88 goals. The record is 138 goals. With 10 games remaining, how many goals does your team need to score per game to break the record? All right, so did they give me a total here?
Yes.
That my total is what? 138. So I'm going to write that, okay, over on the right side. Now I have some combination of the rest of the values that I want to, do I want those values to, well, we'll talk about that in a second. All right, the next thing I look for is this. Is there a value? And your answer might be yes, or it might be no. If your answer is yes, this is a two-step inequality. If your answer is no to this question, it's a one-step inequality. Is there a value in here that will not be affected by the variable?
88.
What is it? 88. 88 goals have already been scored. It doesn't matter how many games are left in the year. Those 88 goals are locked in. Okay, so that's separate. But I do need to know how many goals do I need to score per game for the remaining 10 games to still beat the record. So let me ask you this. And this is the part where there isn't a cut and dry way that I can say, you just do this every time. But there is a thinking process here, guys, that if you can get it, then you should be able to get these inequalities right. Do I want this value to be greater than 138, less than 138? Can it be equal to 138 in order to match the criteria of what it's asking me for? It must be greater than. How do you know that? What in the problem told you that?
Because it's trying to beat a record.
You're trying to break it. So let me ask you this. Could it be equal to, what if I hit 138? Does 138 break the record? No, it ties it. So it has to be greater than. Now I have my inequality set up, and it's just downhill from here. All I have to do is subtract 88. I get 10g is greater than 50. Then what would I do?
5 by 10.
Divide both sides by 10. And g is greater than 5 goals. What does this mean? This means that I must score more than 5 goals in the remaining 10 games. Because if I only score 5 goals in the remaining 10 games, I will tie the record. So in one of those last 10, I must score more than 5 goals. Does that make sense? Okay, that's why it cannot be equal to. All right, because I need to break the record. So if they give you a total, you set it up this way. Now, sometimes you're not given a total. Sometimes you have a problem like this. And let me just kind of note here that number 22 on your homework is just like this problem. In this problem, they give us this information. Let's read it together. You read it to yourself up here on the screen. It says you plan to go ice skating often this winter. The skating rink charges $4 for admission. You can either rent skates at the skating rink for $5 a day, or you can buy your own pair for $45. How many times do you have to use the ice skates in order for the cost of buying them to be less than the total cost of renting them? So here we have what we call an option. Basically, I'm matching up two options against each other. What are my two options here for attending the skating rink? What are my two options? No. $4 for admission doesn't matter. That's the case for both of them. But in one scenario, what am I going to do with my skates? I'm going to buy them. And in the other scenario, I'm going to rent them. And so I'm basically putting them up head to head to try to figure out which one of these, or basically how many times I would need to go ice skating in order to make it save me money to buy it. Does that make sense? Because basically this is what it's asking me. In order for the cost of buying them to be less than the total cost of renting them. So that's basically setting up my scenario. I want to see how many times I need to go in order for buying them to be less than renting them. All right, so I can get to that break-even point. So before I do that, I need to figure out an expression that would represent my total cost if I were to buy the skates. Okay, so this is option one. If I bought them, how much do the skates cost? $45. How much do I have to pay per time that I go? Well, $4. So I just used V for visit. So here now I have an expression that represents my cost to attend the skating rink if I were to buy them. $45 for my skates and then $4 each time I visit. But if I were to rent my skates and go to the skating rink, I not only pay $4 per visit, but I also pay how much per skate rental? $5 per visit. So if I'm renting, when I go, I pay $4 to get in and I pay $5 for my skates, and then I can go ice skating. You see how basically every time you go, you're paying both of those? So that's why it's the same variable. All right? So it's the same variable if it's basically the exact same scenario or unit that you're measuring per visit, okay? So now that I have this, I can match them up against each other. Buying must be less than renting. Whoa, wait, where did I get 9V from? 4V plus 5V, all right? Doesn't matter. Like I said, every time you visit, you have to pay for both, so you can add them together. Those are like terms, 9V. Now we have a two-step equation that we can set up and solve. Go ahead and solve that. Right, so we subtract 4V to the other side and we get 45 equals 5V. Divide both sides by 5 and we get V is greater than 9. What does that mean? What does that mean? V is greater than 9. So going back to the question, how many times do you have to use the ice skates in order for the cost of buying them to be less than the total cost of renting them? You have to go more than 9 times. So here's what it's saying. If you go 9 times, you're going to break even. Well, except now you own a pair of skates instead of having nothing to show for it, as far as, whatever, a comparison. But what if you go 10 times? What happens?
You make money.
You just saved $5 for that skate rental. Up until the 9th time, there's really no difference. But on that 10th time that you go, you just save $5. On the 11th time, you save another $5. And you keep saving money after that versus the person who rents. Okay? You can apply this to several real life scenarios. Like, let's say a washing machine. Okay? Well, a washing machine is not very cheap. All right? Let's just say $500. $500 for a washing machine. But how many years do you think a washing machine lasts? Maybe, let's just say 10 years. So $500 it costs, but it lasts me 10 years. So how much did I pay per year for that washing machine? $50, all right? Do you think if you went to the laundromat, and we're talking every week, you went to the laundromat every week for, you know, an entire year, do you think you'd spend more than $50 washing your clothes? Yeah, you would. Now, there's different scenarios. There's reasons why people use laundromats. Laundromats are still in full force, full swing these days. But, you know, when you're looking at a cost comparison, that's an inequality. And sometimes the initial investment, while it's a lot, it's $500, and that doesn't come easy for a lot of us. While the initial investment might be more, it might save you in the long run. You see that? That's all inequalities. Those types of scenarios. All right. And so anyway, that's it for today's lesson and chapter 3. We're done with chapter 3, and that's everything you need to know.